next concept is gravitational potential. Okay. Now listen very carefully and let us try to understand what is meant by potential. So see. So consider this is a mass of m. This is the main mass, capital M, bigger mass. And at infinity, there is a point mass m0. And what is meant by point mass? Very small mass is called as a point mass. So this point mass is present at infinity. Okay. Now this point mass, I want to take this point mass somewhere up to here. Are you able to understand? I want to take this point mass from infinity to this point P, which is present at a distance of r. Understood? No? Now the question is, shall I need to do some work or not? Okay. I want to bring this one without any acceleration to this point. Okay. So from infinity, so point mass m0 should be brought without any acceleration. Clear, Nama? So in this condition, shall I do some work or not? It means external force, is it necessary, or external force, is it not necessary? Huh? Necessary. Why it is necessary? These are not charges, they are masses. They are masses, no? See, infinity means that position where gravitational force between them is 0. That is called as infinite position. Gravitational force between the masses is 0. There is no gravitational force. That position is called as infinity. Okay, ma? So that point also you can write. At infinity, so gravitational force between masses is how much, ma? It is equal to 0. Now the question is, shall I do some work or not to bring this mass up to this position? Huh? I have to do work. Why I have to do work? So gravitational force between the masses, it will pull mass m0. Clear, Nama? So no need of doing work. But that is also wrong. Okay, anybody? Sima, gravitational field will pull this mass m0, no? So net force starts acting on this mass. So what happens when it starts coming towards this mass, bigger mass m? What happens to the force? Force also increases, no? Arthamatunda? When this mass starts coming to this capital mass, capital M, then what happens to force? Force continuously increases. Because when distance decreases, what happens to force? Force increases. Because according to Newton's law of gravitation, F is equal to G m1 m2 divided by r square. Clear, Nama? So F is inversely proportional to r square. So as this test mass starts coming towards capital M, the force also continuously increases because r value decreases. Okay, ma? So is there any need to do work or not? Again, same question. ఆలోచించండి కొంచెమైనా. I have to bring it without any acceleration. Without any acceleration means what? Without any acceleration means acceleration is 0. Clear, Nama? If acceleration is 0, what is the net force acting on this mass? Net force acting on this mass is also should be 0. But gravitational force is definitely acting, no? Okay, ma? For example, if this mass has reached up to here, then what is the gravitational force? Gravitational force is Fg. Gravitational force is definitely acting, no? Then how net force can become 0? Net force 0 అవ్వాలంటే ఏం చేయాలి? You have to apply an equal and opposite force in opposite direction. That's what you have to do, no? Clear, no? So, as this body starts coming towards the mass, force increases. So, you have to increase your applied force also. So that gravitational force and net force, they will become equal. Then only net force will become 0. Then only body will not accelerate. Okay? It means that definitely we have to apply some net force. We are applying net force and there is some displacement also, no? So definitely work is done. అర్థమవుతుందా అనాలిసిస్ ఎలా చేస్తూ ఉన్నాము? క్లియర్, నామా? ఫర్ మేకింగ్ యాక్సిలరేషన్ టు బి 0, నెట్ ఫోర్స్ షుడ్ బి 0. But gravitational force is always present. So we have to apply an equal and opposite force. So body moves, but without acceleration. With uniform velocity, it will move. If velocity is uniform, acceleration is 0. No? Are you able to understand, ma? Therefore, what I say, therefore, definitely, work must be done. Work must be done. Okay, ma? But what kind of work we are doing, ma? External force, is it doing positive work or negative work? Negative work. Why negative work? Force we are applying in this direction, but body is moving in opposite direction. So angle between them is how much? 180 cos 180 minus 1. So work done is negative, no? Are you able to understand, ma? So, and work done is, work done by whom? Work done by external force is how much, ma? It is equal to 0. Are you able to understand? Because if this is the test mass, clear, no, ma? External force is in this direction, but displacement is in opposite direction. Angle between them is 180 degrees. Are you able to understand? Sorry, work done by external force is not 0, it is negative. Okay. So therefore, how I define gravitational potential is that, gravitational potential, how I define, clear, ma? So this is equals to work done per unit test mass, to bring the unit test mass from infinity to a particular position. Okay, ma? So V is equals to, what is meant by W, ma? Work done. Work done to do what? Work done to transfer a unit test mass from infinity to which position? To a particular position in the gravitational field of the main mass. That amount of work done per unit test mass is nothing but potential. Understood, no? So therefore, what is meant by potential? How much work you are doing to bring a unit mass from infinity to a particular point. That amount of work done is called as potential. Okay, ma? So right. So what is the definition we can write here? The amount of work done, the amount of work done to bring a unit test mass from infinity to a particular point, infinity to a particular point in the gravitational field of main mass. Okay, ma? This amount of work done is called as potential. So what is meant by potential? Potential is basically work done, that's it. Okay? But not only work done per unit test mass. ఒక యూనిట్ మాస్ని ఇన్ఫినిటీ నుంచి ఒక పాయింట్ వరకు తీసుకొని రావడానికి మీరు ఎంత వర్క్ చేస్తారు? దట్ అమౌంట్ ఆఫ్ వర్క్ డన్ పర్ యూనిట్ టెస్ట్ మాస్ ఈస్ కాల్డ్ యాజ్ పొటెన్షియల్. ఆర్ ఏబుల్ టు అండర్స్టాండ్, మా? దట్స్ ఇట్. ఓకే. Gravitational potential, is it positive or negative, ma? Gravitational potential is always negative because work done is always negative, no? Work done is always negative, no, ma? Because work done by external force is in one direction, but mass is moving in opposite direction. So definitely gravitational potential is a negative value. So make a note of that point also. Okay, ma? So therefore what we write, as work done is negative, gravitational potential of any point, gravitational potential of any point is always negative. Okay, that is the point which you should understand. Okay, ma? మీరు చాలామంది వినటంలో రాయడంలో ఉన్నారు కానీ వినటంతో మాకేం పని అన్నట్టున్నారు మీరు. నోట్స్ రాయడం కోసం కాదు క్లాసులకు వచ్చేది. అర్థం చేసుకోండి ఫస్ట్. ఉత్తర నోట్స్ రాసి ఏం చేస్తారు? అండర్స్టూడమ్మా? దట్స్ ఇట్. నౌ లెట్ us do some calculations. So gravitational potential due to point mass. Okay, ma? So there are some calculations, ma, which I am not doing, or if you want you can do it. So work done from infinity to a position r. Okay, ma? From infinity to bring the point to a position r, how much work will be done? It will be force is a variable, no, ma, in this condition. Force is a constant or a variable? Force is definitely variable because as the distance changes, Mudassir Khan, kya karte hain tum? As the distance changes, force of attraction also increases, no? So the force which you have to apply also will change. So definitely force is a variable. So therefore what I will write, it is integration of f dr cos theta. This is the formula which I have to write now when force is a variable. When force is a constant, work done formula is f into s. But when force is a variable, integration of f dx cos theta or f dr cos theta. And what are the limits of integration? This point mass should be moved from infinity to point r. That's all, no? I have to move this one from infinity up to which position? Up to a position of r. Okay, and we know what is the equation of gravitational force, no? So gravitational force is G mm divided by r square multiplied by dr into cos theta. And here theta value is 180 degrees. Are you able to understand? So I am not doing further calculation. If you do this total calculation, clear? Then the amount of work done to move the body from infinity to r, it will be equal to minus G mm divided by r. This is the answer which you will get. Okay, ma? This amounts of work I have to do to move the body from infinity to position r. Understood, no? Then what is meant by potential at that point? Potential at that point means what? Work done per unit test mass. Same equation we write in electrostatics also. Work done per unit charge, there we write. Here work done per unit mass is what we write. Clear, nama? So work done minus G m naught divided by r multiplied by m naught. So it is equals to minus Gm divided by r. So this is the gravitational potential at a point because of any mass. Okay, ma? And here what is capital M, ma? Capital M means main mass. Okay, test mass is not there, no? In this formula, test mass is not there. In the above equation, test mass is not present. If test mass is not present, what do you understand? Test mass ledu ante meeku em artham avutundi? Gravitational potential doesn't depend on test mass. It depends on the main mass. Understood, nama? If main mass is a bigger mass, potential at a point also will be bigger. Similarly, if distance of a point from the main mass, if it is greater, then potential decreases because they are inversely proportional. Understood, no? So in the above, test mass is absent. So potential at a point depends on what? Depends on main mass, but it doesn't depend on test mass. That is the point. This is the main mass, point mass, and the mass which you are moving, that will become the test mass. Earth తీసుకున్నప్పుడు వేరే gravitational field not only exists for Earth only, no? Even for this pen also gravitational field will exist. That's what Newton said, no? Gravitational force exists between any two bodies, not only Earth and any body, not only Earth and Moon. Between any two body, gravitational field is always present. Okay? That is. Make a note up to here. Okay? So, Sima. So, this is a sphere whose mass is 100 kg. So, at a distance of 10 meters from this solid sphere, I want to find out what is the gravitational potential. Okay, ma? So because of this one, here at this point, how much will be the gravitational potential? Can you see? Zero. Zero. Already we have calculated, no? So this is the equation for point mass. But for external points, a sphere behaves like a point mass. Already we have studied, no? For external points, sphere behaves like what? Point mass. So use the equation here. Okay. So therefore, what I write? For external points, okay, ma? Sphere behaves like a point mass. Clear, no? Understood, no, ma? So therefore, gravitational potential at point P is how much? Minus Gm divided by r. So minus G, mass is how much, ma? 100 kg divided by distance is 10 meters. So minus 10 into G. Okay? G value you need not sub 6.67 into 10 power minus 11 Newton meter square per kg square. But no need of substituting, leave up to there. Or if you want to substitute, you can substitute. Okay, ma? And can you say what will be the unit which you will get, ma? What is the unit of potential? Ajayadam kosame problem chesindi. Work done per unit mass, no? What is the unit of work done? Joules. What is the unit of mass? Kg, so joules per kg. That is the unit of potential. Understood, no, ma? Now if you want to substitute a G value, write down minus 10 multiplied by 6.67 into 10 power minus 11 joules per kg. Okay, ma? So you can write it as minus 6.67 into 10 power minus 10 joules per kg. So that is the potential at that point. Okay, ma? And this potential was obtained because of which mass? This mass. Okay, ma? Ee point daggara deeni valla inta potential untundi. It means that if I want to move any test mass from infinity to this position, then how much work I have to do? I have to do this much amount of work per unit charge. That is the per unit mass. That is the meaning of this.
Gravitational potential work is GM by discharge by R.
This one, work done per unit mass. Per kg I got. Per kg means what? This much amount of work I have to do to move 1 kg of mass. That is the meaning of this. Joules per unit chudandi ikkada. Joules per kg. Joules means work done, no? It means I have to do this much amount of work. To shift to how much mass? 1 kg of mass. From which position? From infinity. To which point? To a point of 10 meters. That is the meaning of potential. Understood, no? That's it. Make a note. Now see. So next one what we are studying is gravitational potential because of solid sphere. And when we are taking solid sphere, we have to study 3 points. 1 point outside the sphere, 1 point on the sphere, 1 point inside the sphere. Okay, ma? So already we studied that for external points and for points on the sphere, sphere behaves like a point mass. So write down. Okay, ma? For external points and points on the sphere, or you can say on the surface, solid sphere and shell behaves like what? Behave like point masses. Understood, Nama? They behave like point masses. Okay. Therefore, what I will write, so gravitational potential at point A is equals to, for point mass already we have calculated, Nama. For point mass, what is the potential? Minus gm divided by r. So that's all. This is my equation. Okay. For outside points. And for points on the sphere, minus gm by capital R. Because the distance of surface from the center is nothing but radius. So minus gm divided by R. Okay. Ma? But for inside sphere, for a point which is present inside, okay, for point C, okay, I can write potential at point C is minus gm into 3r square minus r square divided by 2r cube. This is the relation. Are you able to understand? Ma? So minus gm into 3r square minus r square divided by 2r cube. That is the relation. Is it clear, ma? Now see. So this is, and what is meant by r here? R is the distance of that point C from the center. And that point is present inside the sphere. Then this is the equation. Okay? Right. And then we will write some cases. Okay. So see, ma. So minus gm into 3r square minus r square by 2r cube. Okay? Now let us say one case. Case exactly at center of sphere. Exactly at center of sphere. At center of the sphere, small r will become 0, no ma? Center of the sphere means what? This point C goes and settles at the center. Therefore, small r value, small r will become 0. So substitute here. So therefore, potential is equals to minus gm into 3r square minus 0 divided by 2r cube. Okay, ma? Capital R అనేది రేడియస్ రాది. ఎందుకుండదు? దాని రేడియస్ దానికి ఉంటుంది. మనం పాయింట్ ఎక్కడ తీసుకుంటున్నాము? అట్ ద సెంటర్. స్మాల్ ఆర్ ఈజ్ 0. What is meant by small r? Distance of the point where you are calculating the field. That will become 0. Radius of the sphere will never become 0. Clear? So, Sima. So therefore, if I substitute 0, then what I will get? Ma? So this r square and cube will get cancelled, no? So 3 by 2. So minus 3 by 2. So gm divided by r. So this is the equation to calculate gravitational potential exactly at the center of the sphere. Okay, ma? So what is meant by this much of potential at the center? అంటే అర్థమేమి? అది కూడా ఆలోచించండి ఒకసారి. What is meant by this potential? It means that consider there is some point mass exactly at infinity. There is one point mass exactly at infinity. I want to bring this point mass from here to here, this point. Then how much work I have to do? This much amount of work I have to do. That is the meaning of this one. Because at this point potential is this much. Same point mass if I want to move up to here on the surface, then how much work I have to do? I have to do this much amount of work. Clear, Nama? And this work is definitely greater than this work. Miru, if you want to bring very nearer, you have to do more amount of work, no? Work is definitely negative work, but magnitude of work is greater, no? More amount of work you have to do. And definitely capital R is smaller than small r, no? In this condition, small r is bigger, capital R is smaller. So if your denominator decreases, total value increases. Okay? So when compared to this position, here the work done will be greater. Okay? Similarly at the center, now out of this one and this one and this one, which is a bigger potential? Definitely this one, because minus 3 by 2 is there. No? It means that to bring the same test mass up to center, okay, ma, I have to do very huge amount of work. So that is why potential at the center will be maximum. Are you able to understand, ma? So therefore, potential at center is greater than potential at capital R is greater than potential at small r. This is a point. Understood, no, ma? సో జస్ట్ ఇక్కడికి తీసుకోవాలంటే కొంచెం వర్క్ చేస్తే చాలు, ఇక్కడికి తీసుకొని రావాలంటే ఇంకొంచెం ఎక్కువ వర్క్ చేయాలి, మధ్యలోకి తీసుకెళ్ళాలంటే ఇంకా ఎక్కువ వర్క్ చేయాలి. అండర్స్టూడ్? దట్స్ ఇట్. మేక్ ఎ నోట్. సిమిలర్లీ ఇఫ్ ఐ డ్రా గ్రాఫికల్ స్ట్రక్చర్, గ్రాఫ్ ఆఫ్ how potential varies with respect to distance, then graph will be somewhat like this. Clear, ma? So this is a solid sphere, center of the sphere, and this is a graph of potential versus R. Okay, ma? And this is a point capital R. Okay, ma? So this is a position where small r will be equal to capital R. Okay, ma? So from at the center potential is maximum, no, ma? And when coming to the surface, potential slightly decreases. So therefore graph will be like this. Understand? Because at the center, what is the potential? It is minus 3 by 2 gm divided by capital R. Clear? And on the surface, it is slightly lesser. Therefore, what is its potential here? Minus gm divided by capital R. And when it moves out of the surface, that is when point is outside the surfaces, then potential will be like this. Because here V is inversely proportional to R. Understood, no? Why inversely proportional to R? Already we have written the equation, no? For outside points, V is equals to minus gm divided by small r. V inversely proportional to R only, no? It means as R value increases, V value continuously decreases. Okay? అంతే కదా, బాడీకి దగ్గరగా మీరు మాస్ తీసుకొని రావాలంటే మీరు ఎక్కువ వర్క్ చేయాలి. ఓకే? అండ్ బాడీ నుంచి డిస్టెన్స్ పెరుగుతూ వెళ్ళింది అనుకోండి, ద అమౌంట్ ఆఫ్ వర్క్ విచ్ యూ డూ ఆల్సో విల్ బీ లెస్సర్. దట్స్ ద పాయింట్. క్లియర్? This is a very important graph. I think previously in some examination this question was asked. Okay? Okay, ma? So then we are studying about gravitational potential because of a shell. And what is meant by shell? Hollow sphere is called as a shell. Okay, ma? And for external points and points present on the shell, again shell behaves like a point mass only. Clear? So therefore, gravitational potential at point A is how much? It is minus gm divided by small r, because shell behaves like a point mass only. And for on the sphere also, it is minus gm divided by capital R. Okay, ma? And for internal points, for any internal point, okay, ma, gravitational potential is equals to minus gm by capital R itself. Understood, no? What is the potential existing on the surface? Same potential exists inside the hollow sphere also. అర్థమవుతుంది కదమ్మా? సర్ఫేస్ పైన ఎంత పొటెన్షియల్ ఉంటుందో హాలో స్పియర్ లోపల కూడా అంతే పొటెన్షియల్ ఉంటుంది. ఏ పాయింట్ దగ్గర, ఎక్కడైనా సరే, అట్ ఎనీ పాయింట్. ఆర్ ఏబుల్ టు అండర్స్టాండ్? అండ్ ద రీజన్ ఫర్ దిస్ వన్ ఈజ్ సిమా రిలేషన్ బిట్వీన్ E and V is E is equals to minus dV divided by dr. This is a relation. Okay, ma? What is meant by E? Gravitational field. And what is meant by gravitational field? Force applied per unit test mass. Definitions gurtunnai kada? Force applied per unit test mass is called as field. And what is meant by potential? Work done per unit charge is called as potential. So relation between field and potential is this one. E is equals to minus dV divided by dr. Are you able to understand, ma? So inside a shell, E value is 0. Already we have studied, no? In the last classes we have studied, no, ma? Shell lopala field ఎంత ఉంటుంది? ఉండదు. There is no field. Because if you take any point, force acting on the total point will be 0. Net force will be 0. So field also will be 0. So therefore, if E is equals to 0, then minus dV by dr also should become 0, no ma? Clear, no? And dV by dr can become 0 only when V is a constant. So based on that logic, we are saying that inside the hollow sphere, field is definitely 0. Potential is not 0. Potential is a constant. Understood? And how much will be that potential? What is the potential existing on the surface? Same potential will be present inside the total volume of the shell also. Okay, ma? Therefore, what we write, therefore, potential on the shell will be same as potential throughout its volume. Potential throughout its volume. Understood, Nama? What is the potential existing on the surface? Same potential will be present throughout its volume. See, for example, if I take point C and if I take one more point, point A, one more point already I have taken, no? Let us call this point as point D. One more point I will take point E, and at the center I will take point F. Okay? All these points, they are inside the sphere, no? Therefore, what I can say, potential at point D is equal to potential at point E is equal to potential at point R is equal to potential at point C. Only 3 points that I have taken, no? Point F, 4 points. Clear now? All the potentials will be same. And this is exactly equal to potential at point B. And what is meant by potential at point B? Potential on the surface. And how much is the potential on the surface? So it is minus gm divided by capital R. That's all. Understood, no? That's it. Make a note up to here. Okay, ma? Now see, ma. So if I want to draw a graph of how potential varies with respect to distance, on y-axis we will take potential, on x-axis we will take distance. Clear, no, ma? See, already we studied what is the potential at the center. Same potential will be at the surface also, no? So therefore, how can I draw the graph? Okay, ma? So it is constant. Okay? From center to surface, potential is a constant. This is the position capital R. Surface. Okay, ma? And from the surface, what is happening? From the surface, for external points, it is minus gm divided by R, no? It means as the distance increases, potential decreases. So graph will be like this. Okay? Why? Because potential is directly proportional to 1 by R, or inversely proportional to R. That's it. Era. Straight line, Laura. It comes as a inverted graph. Okay? Okay, ma? So see. So next we are discussing about potential due to uniform Rigma. So what is this line? This is the axial line. Okay, ma? Axial line means we have understood now, if this is the ring, this is the axis around which this ring can rotate. So line drawn through that point is called as axial line. Okay. So this is the axial line. So at a distance of x from the center of the ring, here at point P, I want to find out gravitational field, not field, gravitational potential. Understood, Nama? So direct formula also we can write, but here we will see a small interesting derivation is there. See, what I do is, I will take a point mass. I will take a differential mass dm, total mass is capital M, on this ring. Okay? Which in a differential mass, whose mass is dm, very small mass. Then this very small mass, it behaves like a point mass, no ma? Adela behaves chestundi, point mass laga behaves chestundi. Clear, no? And because of this point mass, at this position, let the distance be r. So what will be the position potential here because of this small mass? So because of dm, potential at point P is equals to minus g dm divided by r. This is the formula. No? Because of point mass, what is the formula of potential? Minus gm by r. So minus g. M means which mass I have taken? Tm. So dm divided by r. Satisfied? No? Minus g dm divided by r. Okay. Now if I want to calculate potential because of total ring, what I have to do? I have to integrate. This is a dVp. Small potential because of small mass. Okay, ma? And now see. Now listen very carefully. So here I will take one more point mass dm. Okay, ma? So because of this dm also, here there will be some potential, no, ma? Okay. And because of another dm, let us call it as a dm1. Okay, ma? And this is a dm2. So because of dm2, what is the potential at point P? It is also minus gm divided by r. Okay. Now what is the direction of potential? Anybody? What is the direction of this potential? What is meant by potential? Work done per unit mass. Work is a scalar quantity or a vector quantity? Scalar. So work, does it have any direction? So potential also does not have any direction. Are you able to understand, ma? So just potential, because of all dm's, they will get added up, that's all. Okay, ma? Potential at point P because dm1 is this much. Potential of point P because dm2 is this much. All of them, they get added up, that's all. Because potential is a scalar quantity, it is not a vector quantity. Are you able to understand, ma? So make a note of this point. Note point is that, before only I should have said you, but I forgot, so write down. So potential is nothing but work done per unit mass. Clear, ma? And work done is a scalar. Therefore, potential is also a scalar. Potential is also a scalar quantity. Understood, ma? Therefore, potential due to all point masses gets added up. Because magnitude is same, nama? Every potential is negative only. So all the potentials will get added up. And what is meant by that one? So potential at point P is integration of d into Vp. That's all. No? Addition is nothing but integration. Just integrate this potential due to point mass, then you will get potential due to total ring. So integration of minus g dm divided by r. Now three terms are there. First term, second term, third term. Out of them, which is a constant, which is not a constant? G is a constant, r is also a constant. For every dm, distance remains to be r only, no? Okay, ma? Therefore, r is also a constant. So take them out of integration. So minus g by r, g by small r, integration of dm. Okay, ma? Dm means small mass. Integration of dm means total mass. What is the total mass of this ring? Capital M. Substitute. So therefore it is potential at point P is minus gm divided by r. So again you got equation because of point mass only, no? Minus gm by r. What is this equation? Potential for point mass only. But what is r value? This is x, this is n, r can be written as square root of r square plus, x square plus a square. Can I write like this? A will become r will become a hypotenuse, no? So Pythagoras theorem. So apply here. So minus gm divided by square root of x square plus a square. That's all. So this is the potential at point P. Understood, no? Okay. So this derivation I have done so that you can understand actually what is happening. Okay, ma? And this is one point which we have understood now. Potential is not a vector quantity, it is a scalar quantity. It doesn't have any direction. But same field of a ring, we have calculated previously, no? Field of a ring. There we have taken directions when we have calculated some, cancelled some differential fields in opposite directions, all that we have done. Here there is no concept of cancellation because potentials will get added up with each other. They don't have any direction. Understood, Nama? That's it. Similarly, if I calculate potential at center of ring, okay, ma? Case. Potential at center. Center means R value. Center means X value. X value 0. Point is here, Nama. Instead of this point, I will place here. Then X value will become 0. So therefore, if X becomes 0, potential at point B is how much? Minus Gm divided by root of A square is A. That's all. This is my answer. Okay. Understood, no? So now can you say potential at point P is greater or potential at center is greater? Huh? Definitely potential at center is greater, no? Because here denominator is bigger, but here denominator is smaller. It means exactly at the center of the ring, potential will be maximum. Understood, no? Therefore, if you draw the graph of this ring also, okay, ma? So this is the center and this is the surface, okay, ma? And this is the graph. This is potential and this is R. R means here X I have taken, no? X. X means distance from the center. Okay. So graph will be somewhat like this. How the graph will be? Ma? Graph will be like this. Like this. What is the meaning of this one? It is maximum at the center. When I move away on the right side or on the left side, potential decreases. That is the meaning of this graph, no? Potential maximum ekkada undi chudandi. Potential is maximum at center. As you move away from the center, numerator denominator increases, no? If denominator increases, potential decreases. That's it. Fine? Make it.